Welcome back to the Dr. Liu VCE Physics channel. In this video, we'll be going through the 2018 physics exam, focusing on questions related to Newtonian mechanics. My explanations may not be perfect, so if any teachers, parents, or students notice any errors, please feel free to offer your feedback. When four forces act on an object, you can find the single resultant force by first establishing an xy coordinate system. Next, calculate the x and y components of each force. Then, find the sum of all x components and all y components. Finally, use the Pythagorean theorem to calculate the magnitude of the resultant force. Since Lisa's reaction time is 0.5 seconds, the actual breaking time is 2.5 seconds, 3.0 s 0.5 s. According to the impulse-momentum theorem, the impulse of the braking force is equal to the car's change in momentum. We can rearrange this relationship to calculate the average braking force acting on her car. When a railway truck X collides with and joins a stationary railway truck Y, they form an isolated system where total momentum is conserved. This relationship allows us to calculate the final speed of the coupled trucks. For convenience, the unit of mass can be kept in tons, as it will cancel out on both sides of the equation. Following the collision, the trucks join together. This causes a loss of kinetic energy, as it is converted for the coupling. Despite this, the total momentum is conserved because the system is isolated. This is a classic example of a perfectly inelastic collision. When a ball is dropped onto a spring, the conservation of mechanical energy can be used to analyze the system if air resistance is ignored. The initial gravitational potential energy of the ball is converted into kinetic energy, and then into the elastic potential energy of the compressed spring. This relationship can be used to calculate the spring constant. The ball's maximum velocity is reached at the instant its acceleration is zero. This key moment occurs when the downward force of gravity and the upward force of the spring are in perfect balance, resulting in a net force of zero. Before this point, the ball is accelerating because gravity's force is greater than the spring's force. At this point, the forces are equal, so the acceleration is zero and the velocity is at its maximum. After this point, the spring's force becomes greater than gravity, causing the ball to decelerate until it stops at the point of maximum compression. As previously analyzed, the ball reaches its maximum speed when the gravitational force is perfectly balanced by the elastic force from the spring. This relationship can be used to calculate the spring's compression at that specific moment. When two blocks, A and B, are pushed together, they move as a single, coupled system. Therefore, both blocks have the same acceleration. This relationship allows us to first calculate their shared acceleration. To then find the force that block A exerts on block B, we must isolate block B and analyze it independently. According to Newton's third law, the force exerted by block B on block A is an action-reaction pair with the force block A exerts on block B. These two forces are equal in magnitude, but opposite in direction. Therefore, since the force from block A on block B was calculated to be 8.0 n, the force from block B on block A also has a magnitude of 8.0 n, but it acts in the opposite direction, to the left. This section of the exam covers Newtonian mechanics and is worth 15 marks, contributing 11.5% to the total mark. Multiple choice questions, 4 marks, question 5, focuses on using vector addition to calculate the resultant force. Question 6. Apply the impulse momentum theorem to find a braking force. Questions 8 and 9 deal with an inelastic collision, requiring you to use conservation of momentum to find the final speed and explain why kinetic energy is not conserved. Short answer questions, 11 marks. Question 6 requires using the conservation of mechanical energy to calculate the spring constant. You also need to determine the ball's acceleration at maximum speed, which is 0, and the corresponding spring compression. Question 8 involves a two-block system and asks you to use Newton's third law to find the force between the blocks. Should you require assistance, please feel free to connect via WeChat or WhatsApp and send an email. Thank you for your attention. Kindly note the details of Dr. Liu's VCE Physics, Chemistry, and Biology channels.